Hello there! In this lesson we're going to learn about limiting reagents. So limiting reagent is an issue that you'll have with chemical reactions sometimes when the amount of one reactant doesn't match exactly with another reactant. So you can, a good analogy is when you buy hot dogs, they rarely come in the same quantities that the buns come in, which means you're always going to have some leftovers unless you buy the exact right proportions of each. So let's see how that works. So here you go. Here's the same example. We've got 12 hot dog wieners and we've got 8 buns, which means we can make 8 hot dogs, complete hot dogs, and then we'll have some leftovers. We call the leftovers excess. That's excess reagent. So the same thing happens with chemical reactions. If you don't have the exact right quantities of both, you'll have leftovers. You'll have excess reactants that don't react and just sit around there. So how are you going to tell whether or not you have a limiting reagent situation where you have to take this excess or limiting quantities into account? Well, we're going to use the reactions out of a fuel cell as an example. First of all, there has to be more than one reactant, and then we have that here. We've got oxygen reacting with hydrogen in the fuel cell. And then we have to have some clue as to how much of each of these, or the quantities. So if you don't know the quantities of both, then you can't really work out limiting reagent. So let's look at these two questions below. So the first one says, what mass of water is produced when 6 grams of oxygen reacts as above? Well, in order to answer that, you have to assume that enough hydrogen is present. Otherwise, you can't really answer that. So that's the type of problems we've been doing thus far. We're just assuming that it all reacts. And if it didn't all react, there's no way to really answer that because you wouldn't know how much of it to use going forward. The second one is one where we definitely need to work out a limiting reagent because we're given 6 grams of oxygen and 3 grams of hydrogen. So which of those is going to run out first? Which one is the wieners? Which one is the hot dog buns? So that's recognizing when you need to do a limiting reagent. You're going to have quantities of both. So once you know that you need to find the limiting reagent, then the trick is deciding which one is going to run out first. So what you can do is you can work out the amount of the one reactant that is needed to react all of the other one, and then see if you have enough. So we'll do that with both of these, and then we'll compare to see if we can decide which one's limiting. So first of all, what mass of hydrogen is needed to react all of the oxygen? So I'll write mass of hydrogen equals, and then we have 6 grams of oxygen. So 6.0 grams of oxygen. We're going to do our stoichiometry. First convert to moles, 32 grams per mole of oxygen. Then we're going to use the mole ratio. There is 1 mole of oxygen for every 2 moles of hydrogen reacting, right? We got our coefficients that we're using there. And then finally, the 1 gram, actually it's hydrogen, so it's 2 grams of hydrogen for every 1 mole of hydrogen, and that should tell us the mass of hydrogen needed. Down below here, we can work it out the other way. We can work out the mass of oxygen needed, and we'll start with the 3 grams of hydrogen. And so hydrogen is 2 grams per mole, and the ratio goes the other way. We got 2 moles of hydrogen reacting for every 1 mole of oxygen. And then oxygen is 32 grams per mole. And that'll give us the grams of oxygen needed, O2 or H2. All right, so I'm going to work those out. I'll be right back. Okay, so I worked them out, and I found that there is 0.75 grams of hydrogen would be needed to react all of the oxygen, and 24 grams of oxygen would be needed to react all of the hydrogen. So either one of those leads you to the same conclusion. If we're looking at the first line here, what mass of hydrogen is needed, we only need 0.75 and we have 3 grams, which means there's going to be excess hydrogen. And then if we did it the other way, the mass of oxygen worked out, we would need 24 grams of oxygen and we only have 6. So this is limiting. So you can tell with either one of these, so you only really need to do one, and you'd be able to tell whether the other one was limiting. So the limiting reagent is definitely the oxygen because you have both options here. If you did the first one, there is excess hydrogen, or it could be there is not enough O2 to react all the hydrogen. So either one of those calculations would tell you which one is the limiting reagent. So now I'm going to do an alternative method for finding limiting reagent that uses both the starting quantities to make the conclusion. You'll see it ends up being the same conclusion. It's your choice which one you want to use. So for hydrogen here, I have 3 grams, and for oxygen, I have 6 grams. And first off, you convert both of those into moles. So hydrogen is 2 grams per mole, and that'd be 0.66 moles of hydrogen. And oxygen is 32 grams per mole. And if I divide that, I get 0.20 moles of oxygen. Great. So this is a kind of a useful method because you're already doing the first step of stoichiometry, and you can use this quantity of moles to go forward. You just need to know which one is the limiting one. So the trick to find the limiting one is once you have the moles, you divide by the coefficient. So divide by coefficient. And then the smaller value is the limiting reagent. So the coefficient for the hydrogen was a 2, right? And the coefficient for the oxygen is a 1. And so what you end up with here is 0.22, and this is 0.20. So that means this one is the limiting reagent. Now, this is great. You know which one's the limiting reagent. You can now use that value to work out your any stoichiometry you need to do from there. But there is a trap in that some students will use this value rather than the mole value, and it can cause problems. Now, no problem with this one because the divided value is the same as the actual number of moles, and that was our limiting reagent. But imagine if the hydrogen was the limiting reagent, and I went on to solve my problem using this 0.22 value, which doesn't really have any units, but a lot of people get mixed up and they forget that the moles are back here. So it's up to you. You can use it, just be careful, or you can use the other method that uses stoichiometry, your choice, and you'll get the same result. Okay, to finish the problem then, once you know which one's the limiting reagent, we've done it twice and we know both times we came out with oxygen being our limiting reagent. Once you have that, then you can solve the problem with just normal stoichiometry. So the only thing we really added was determining which one of 2 possible reactants or more, if that was the case, is the one that controls the quantity of product that can form. And so again, it's pretty straightforward. Just use your normal factor label method. We'll use the 6.0 grams. You always want to start with your limiting reagent, and that was our oxygen, 32 grams per mole of oxygen. The ratio is 1 mole of oxygen to 2 moles of water, and then water, of course, is 18 grams per mole. And that will end up with giving your solution, right? Moles cancel out, moles of water cancels out, and you end up with a mass of water. So on my calculator, that comes out to 6 divided by 32 times 2 times 18 equals, look at that, 6.75, which amounts to 6.8 grams of water. Awesome. Now, using your limiting reagent can also help you to determine how much is left over, which are your excess reactants, right? So all you do is you use your limiting reagent to work out how much of the excess reagent is used up, and then you subtract from what you started with. So we're going to start with by finding the mass of hydrogen used, and we'll start with our limiting reagent, oxygen, and again 32 grams per mole of oxygen, and then we'll go to the mole ratio. We're going to go from here to here this time. So 1 mole of oxygen for every 2 moles of hydrogen. And then we know that the hydrogen is 2 grams per mole. And so do that one, 6 divided by 32 times 2 times 2 equals, that equals 0.75 grams of hydrogen. Now, that's hydrogen used, right? That's hydrogen that got used up. So if we want to find how much remains, so remaining hydrogen equals, we have that 3.0 grams that we started with, and we're going to subtract the 0.75 that we used. And this is the start. And then you know that that would leave us with 2.25 remaining, and we'd have to round that down to 2.2 grams to give us the right number of sig figs. Okay, there you go.